Hello engineers, today we're going to be looking at lights, but before we do that I set you the task last video of doubling the length of the bridge. Now I just had a look at that and I thought it would be as simple as just putting a second piston on the back here, but actually this piston is attached to the platform at the top here, so this won't move, you can't push this out, so we're going to have to actually do a little bit of redesigning here, and probably rebuild the whole thing, honestly. My idea is we get rid of the solid blocks that are gluing it, and we just replace all these with panels across the top. Let's see, like that. Right, now the whole thing's actually detached, and the bridge will now no longer work. Yeah. Now, I would say that even if, so we can put that there, we put it one in, it doesn't like gluing directly onto the back like that. And we end up with a gap anyway. So that when we build the next one, why is that not? Oh, it doesn't like the fact that there's a piston head there, right? Okay. This is fine. It looks like we'll have to set one of these pistons to have a minimum retraction of like a meter or whatever the width of one block is. Right. Let's delete the rest of this. Now, we had, I think, 0 on top. Then a slope. And a block. And then panels along with them. Can't remember how many. We'll do a test. Okay. Now, what was our programmable block looking for? We can put these back now. These weren't actually in the way. Huh. Oh. This won't work now because the names will have changed. Pretty sure it was piston lowercase, and on 2. We'll make it. Now we go into, actually let's see. Oops. Code, what was it waiting for? If it receives extend, extending is true, piston dot velocity equals 5. Okay, let's recompile. Okay, we recompile and it says it now can't find something. Right. What could it be having a problem with? It's looking for the piston, which is called piston. That should be fine. The rotor, that's what's missing. Yep. Okay. So now we should have what we had before. Let's see if I'm gonna. Yeah, it's gonna break. Let's stop that there. Okay, so that still works. Now all we need to do is figure out argument retract. Extending true. If. Right. So it's waiting for the first piston to reach full extension. So what we need is, and also piston 2 current position equals 10. But we don't have piston 2 yet. We need to add that guy here. And then we just copy piston 2, look for piston 2. We don't need to set this stuff because that's the default anyway. Yeah, that should be it. And then it's and piston 2 dot current position equals 10, and only when they're both fully extended do we give the rotor a velocity. Now retracting. We need to tell the second piston to also have a velocity of -5. And up here a velocity of 5. And is that all we need? Let's see. Wow. That was fast. Apparently, yes, that was all we needed. So, not terribly complicated as it turns out. Let's just make the bridge long enough. Does it retract right? There we go. Done. Right. Lights. Now. Oh no. The texture changed. That's not the right button. That's not the right texture. Where is it? Some gritty. Is it concrete? Yeah, it's concrete. Oh, isn't there a way of, like, no. No. Ah, that's definitely not what I wanted to do. Cut this part out. Let's start with a nice festive colored programmable block. And a light. Okay, and we will call this light just light. I'll just do stuff with just one light. And I've created a shelter here so that we'll have some darkness so you can actually see what the light's doing. Now, unfortunately, for some reason, the sun just stays overhead the whole time. It never goes underneath, so we always have some kind of sunshine shining down upon us. But for a while, we'll get some darkness, right? Now the light, you can set the color, you can set how much reach it has with the radius, you can set the fall off, full, it's full bright, basically all the way to the edge of its reach. If you set that down, you end up with a fade from the origin to the edge of its range, so it's a bit more of a gradient to it. The intensity is how much power it has, I guess. It's very Where's that normally? Very bright, not bright. Offset changes where the origin is. Let me put the radius up a bit so you can see what's happening. The source of the light is moving away from the surface upwards. So it's now hovering up here somewhere. We'll leave that where it is. You can make it blink, so it's a half a second. Blink length, you can make it 50%, which means it's on the same amount of time as it's off, or you could weight it towards being on most of the time and just flickering off, or being off most of the time and flickering on. Blink offset is only really noticeable when you've got two lights blinking. It puts a delay before the blinking starts. So for example, if I have a second light, and this will be relevant for later as well, we'll call this light 2. And light 2, we set the blink length 50, blink interval half second, blink offset 0, and then light 1, blink offset is 50. You notice how, hang on, they're not at the same interval. Right, blink interval, that's 0.5 seconds. Blink interval, 0.7, there we go, it has to be 5. Right now, they'll be on and off at opposite times. That's what the offset does. Now, let's just stop that because that is a bit mad. Now, in code, let's grab the lights. I will say, now the interface type is my lighting block. Lights, and I think you can do it like this. Just cue them all out. Does that work? Yep. So instead of putting 2 lines of the same type, you can just add them all on the same line. It's just a little shortcut. It's up to you. And we do the usual grid system. My big club fingers are hitting all the keys. Get block. Here's the name. And then it's just light. And then it's as my lighting block. Copy that. For the second light, move the closing bracket back to where it was. This is all good. Now, light dot. Now, what we can do, right, radius is the most obvious thing to play around with first. This is the range of the light. And you see it, it's down. 10, I think 10 is possible. What is actually the limit? Radius, yep, 10. It goes as high as 20. Put it on 20. Okay. Let's mess around with the color next. it's the alternate spelling. New. I think it's just you put 3 numbers in for the R, or red, green, and yellow values, blue values, red, green, and blue values, RGB. Maximum number you can put in is 255, or 0 is the minimum, and that will give you white, which changes nothing. So let's change that to 0 for green, and you'll get magenta. Let's put a 0 for red, and you'll get blue, and so on. We can set the blink interval here. Not 0.1. Remember, float, otherwise it will think it's a double, and it goes mad. Half second. Full second. Alright, and now what we'll do is we'll grab the second light. 2 dots. And we'll basically copy all that, actually, for brevity. And we'll just put 2, 2, 2. Now what we'll do is we will set the what was it? The offset, blink offset. I think it's just 50. And that has not worked. Oh, hang on. Is that because we've still got the... Yeah, we've still got the first one on blinks offset. So I've actually just set them to the same blink offset. There we go, that's done it. See, that's already on 50% offset from when we were playing with the settings in the UI earlier. Let's make this one red. This one green. Actually, yellow. RG. RGB. RGB. Yellow has got to be... Hang on. That's magenta. What's this one? There we go. Red and... It's supposed to be yellow, but because it's flashing yellow onto a blue surface, it looks like it's making green, so it swings and roundabouts, isn't it? Right, let's put this to use. Can you guess what it is yet? Oops. Okay, build something similar to that. It doesn't have to be exactly the same. It just needs the lights, like a collection of lights on something. And the way we're going to summon these lights into code is going to be slightly different to what we did with the individual ones. I'm actually going to just... I wish it would take out the entire floor. I can't be bothered to change the texture. Right. What we're going to do is we're going to grab all of them and stick them in a list. What I want to do first, yeah, I'm going to, am I going to rename them? Do I need to rename them? I'm not sure if I needed to rename these or not, or whether they can be any order. Honestly, I think we're going to start with them being just any order until we find out that that's not going to work. That's what I'm going to do. So we're going to select them all, just the lights, all the interior lights, and we're going to put them in a group. And I like to put my group names in all caps. It's whatever, you know, just name it whatever you want, as long as you remember what you name it. And we're going to create a list. Not all caps. Guys, capital L. Is it? Hang on. My mind has gone blank. I think it's capital L. Yeah. Of my lighting light. Oh, my club fingers have struck again. Lighting lock lights. Yes, that checks out. Okay, and you might as well initialize it here because otherwise it's null, and you have to do this at some point anyway. So it might as well be now. And you just copy that. Give it some empty brackets for the arguments, of which we'll have none. Right. We're going to comment out. Well, we'll come at this. These don't work because we've just gotten rid of the lights that we were referring to there, so we'll comment them out. What we want instead is the grid terminal system. We want get, what was it, get block group, isn't it? With name, which is fairly self-explanatory. And now all caps, lights. And I think I've gone wrong here because what this passes back is going to be a generic block type rather than anything specific. We can't set a specific type here because you could potentially group up a whole bunch of different block types in one group, and then yeah, it could be anything. So they have to be a type that spans all of those, which is my terminal block. It just means that we'll have to cast to a specific block when we want to do something specific later on. Light doesn't exist. Yeah, I've got all this. Comment everything out. We'll want these lines, so I'm going to keep them for now. We just have to target them slightly differently. I'm going to count I'm going to count what comes back. My lock group light group equals, right, this is where your group will get stored, and the way you get the blocks out is you say light group dot get blocks, and then you take your list and put it in as an argument, and it will populate that list. And now hopefully we can echo out a count for that list and confirm that it's actually grabbed the lights. Okay. There we go. It has grabbed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 lights. Okay, now we, instead of targeting individual lights, actually no, we can target individual lights just to check this is working. Light. You have to target an index in the list. Every item on the list will be assigned a number from 0 to however many are in the list, and you target the number with square brackets. Now let's go for the first item on the list, which will be 0, and then what we can do is we can do what we were doing before. Affect its various properties. Does not contain a definition for radius. Here's the problem. Here is the problem. No. My terminal block does not have this property. What we have to do is create a variable, my lighting block light equals, and then we take the lights object, lights list, and we grab the first item off it, and we say as my lighting block. And now this variable we've just created is what we will be trying to affect instead. The type name my lighting block could not be found. I've just messed up the spelling. Lighting block. Okay, and then we cannot tell if that has done anything because the sun is too bright. So I'm just going to use my godly powers and move the sun behind the tree. There we go. Now, what have we set the radius to? We set radius to 20 maximum. What was... Let's set the color instead. Just grab that. Light. Okay. And it has... Is it that one? Is that yellow? I might have picked a more obvious... let's go magenta. Magenta is easy to spot. Something's making a magenta color. Yeah, there we go. Apparently, that is the first light on our list. So what do we do if we want to change all of the things all at once? Right, there is a way of going through every single light, and it's a loop. So we'll go every single my light block, and I think this automatically casts for us. I'm going to unfortunately have to comment these out because I can't use the same name twice, it'll complain. In, and then we just put our collection, which is the lights. And what this means is, for each of the items in lights, we will have an opportunity to affect it inside the body of this loop. So if we do something with light in here, it's going to adjust the one we're currently on. So the first time this loop goes around, we'll be doing something with the first light in the lights list, and the second time it goes around, we'll be doing something with the second light in the lights list, and so on. So this basically will run 12 times. And we will be grabbing these. Uncomment, uncomment, indentation discipline, and go. And it's ignored me. Check code? Oh, because it's horribly wrong. Open bracket expected. Where? Well, this can't be wrong because it's commented out for each. Tell me that's supposed to be one word. Have I done a gaff? Oh yeah, it's supposed to be one word. There you go. Boom. Oh, look at all that. Isn't that beautiful? That magenta is so overpowering that you can't even see that the tree is green anymore. Okay. Right. Now, instead of turning them all magenta, let's set them to a selection of Christmas type colours. And the way we'll do that is, instead of setting it to a hard-coded colour here, what we're going to do is have a list. Just like our first list, we'll have a second list with a bunch of colours stored in it, and then what we'll do is randomly select one every time we set a lights colour. So list of colors, list of colors. Is it capital? I think it's capital. We'll never know. Let me just check that. It is. And remember that it's the alternate spelling. Right. And now we have to populate this. And we'll do that in program. Right. It'll have to be somewhere early on. Oh, we can get rid of that now. We're not going to use that. Lighting group we keep. And we'll do it before lighting group. What we actually need to do, we can probably actually just do it at the top, because what you can do is you can immediately fill a list by just putting some curly brackets and then just adding in some new color type items. Right, we'll just go through the primary colors. Red, alternate spelling, and no, it's not end line, it's comma, and you just keep adding, and it didn't like that. I'm going to have to do it like this. Oh my. Why you gotta be difficult? Right. Red, green, and I'm not sure about blue actually. Red, green certainly are Christmas colours. Red, green. What we can do is we can help ourselves by putting a comment after. Red, green, and the compiler completely ignores these, so it's not going to mess things up. Blue, yellow. Yellow kind of is like gold, so yellow is definitely on the cards. Magenta sort of passes. Yellow, magenta, cyan is no. Do we want more than 4? I'm not sure we want more than 4 at the moment. Get rid of that trailing comma. Alright, green, RG. Yellow is red and green, I think it was. And magenta is red and blue. And they don't have to be full garish. We could lower these numbers a bit to make it a little bit cozier, but this will be fine for now. Now, what we need is, at the point where we set these colors, instead of that, what we do is just go, oops, not caps, colors, and then we index. We can index to 0, and then they're all red. We've assigned the first one on the list, and the second one on the list will be green, and then so on and so forth. But we want a random one. So what we have to do is generate a random integer from between 0 and 3. 0, 1, 2, 3. No numbers beyond that because we'll cause an error trying to select an item that doesn't exist. So we'll need a random object. And we'll put that here. We'll call it Randy equals new random. Check that checks out, right? Now, every time we need to generate a new random number, we just say I want an integer, because it by default generates integers. Rand number equals, and we say Randy dot next. And now in the arguments we can set the limits. There are two arguments. There's the lower limit and the upper limit. The lower limit will be 0. The upper limit will be 3. But I don't like hard coding things, so what we'll be doing is colors dot count and -1, because the highest index on a list will always be the count -1. This way, if we ever add colors to this, this will just automatically compensate, and we don't have to go through all the code changing the upper number of the list. That saves a lot of time, believe me. Right. Now let's use that number. What we have to do is just copy it in place of the index. And that will give us, yep, that seems to have given us, where's the sun? Is the sun still behind? Yeah, it is. It's not clear. I think we've got too many colors that don't really show up. Are these all set to radius 20 meters for some reason? Yeah, that's probably what's going wrong here. Yeah, we set them all to, let's set them all to 2. Oh, that's much better. Oh, there we go. You can really see. And every time we recompile, it generates a new set. Yellow isn't really distinguishable because of the green background, which is unfortunate. I do feel like maybe we should be including blue there just for some variation. So let's add a new color. Red, green, and blue can go as the last primary color. Okay. One blue creeping in. All right. Good enough. Now, you'll tend to get a few different settings with your average Christmas lights. They'll blink, they'll do sequences. Let's see if we can get something like that going. But first of all, let's tidy some of this up. What I want to do is I want to set up, well, I want to put in a setup so that we reset the lights to their basic settings whenever we change what mode the lights are in. So let's set a few more properties here. Light dot fall off equals 3. We'll probably want to reset the blink speed. Interval val seconds equals 0. So stop any flashing. We don't really need the. We can put an integer there. That doesn't cause a problem. And intensity, probably a good idea. It's just it's got a weird way of pasting. Intense. What's going on? Intensity. Spell that all correct. Intensity can be 8. What's the radius? What does 1 look like? Oh, 1's quite good. Okay. Now, I'm going to move this initial code into my own function or method so that I can call it anytime I want. You don't necessarily have to say private. This is an accessor. Public means that this can be reached from outside this code, namely in the game code. If you're going to write anything, private is the default unless you absolutely need it to be accessible from outside where you are. I'll set up. I'm going to say reset. Whoops. That's not the right bracket. Oh, take a screenshot. Cool. And then we're going to move. Yeah, that's all deletable now. Let's not leave confusing comments in. X to cut, and there we go. So at the start in program, we're just going to call reset. And what that does is, if you're not familiar with function or method calling, when the thread reaches this, what happens is the thread then jumps to reset, runs the code in here, and then jumps back and carries on afterwards. So we should find that assembly is not found. And why is that? Why is that? The name Randy does not exist. Oh yeah, that's true. We need that as well. It's missing. Oh, I didn't put a closed bracket. I put another open bracket. Right, cool. Recompile. Yeah, now it's doing exactly the same thing as it was doing before. So what we'll do is we will set up a way of changing the sequence to something like just getting them to flash, I think, or fading. Fading's nice and gentle, doesn't hurt your eyes. So what we'll do is we'll set up, where am I? There we are, a button panel. There or there? Let's put it there. Can't get over you. Uh-oh, that sun is peaking again. Let's get it back there. Right, we will set this Actually, we'll set that as the reset. So go in, and as we have done previously, inside main, we'll check the argument that's coming in. Double equals, does it equal reset? If it does, we run reset, which will run this, which means we now should be able to, reset the lights from this button. And we'll make the second one fade. Okay, what we want to do is have this main running again and again. Basically have the block trigger again and again, and every time it does, we affect the brightness of every one of those lights down until it's nothing, and then reverse that and have it increase the brightness of the lights constantly until it reaches its maximum, and then just keep going down and up and down and up. Run the fade function, call the fade function, which we have not written yet. Okay, no, we don't. We don't call it. We just, what we're going to be doing is establishing what mode we're in by setting a boolean is fading equals false, and we'll be setting that to true. Likewise, well, counter to that, if we press the reset button, we really need this to be set to false, because we'll just want the lights to go back to being just on. Otherwise, it will just go back to fading the lights in and out. Okay. Okay. Now, inside main, the second part of main, we'll be checking the booleans. If is fading, and just that, because that's going to be either evaluating to a true or a false. If it is true, then we change the lights. What we want is another for each. And just like we did with reset, we want to go through and change some properties to make this happen. If light dot intensity is what we're going to be affecting. Now, intensity, it goes from 0.5 to 10. So we want to have it increase by 0.5 or so until it reaches 10, and then we reverse it and we have it reduce by 0.5 until it reaches 0.5, and then it goes back to raising it again. So this will just be keep sweeping back and forth. So if it is, light intensity is greater than 0.5, float, Then we will light dot intensity equals now minus 0.5 volt. Now you can write it like that, or you can do this, which is minus equals, and that's a shortcut way of just saying take whatever's there, take this number off of it, and then store it in there again. And you can add by making that a plus. Just a little bit quicker to write. Now, actually, what I think I need to do here is have another Boolean. Yeah, we need a second Boolean here. We need one for the setting. And this is the one that will be changing in main. If setting fade and setting fade. So when we click the button, it sets setting fade to true. And if setting fade to true, then we run fade. And then while we're in here, it is going to be a question of if is fading, then we run the code that makes it go dim. And we have to indent it all. Oopsie. Not too far. Right. If it is currently fading, then we do the fading thing. And then else. And then we just do the opposite. And if intensity is less than, is it 10? I think it was 10. Then keep adding. Now we also have to have some way of triggering the reversal. So if the light is greater than 0.5, continue dimming, but if it's not greater than 0.5, if we've actually reached 0.5, what we need to do is say is fading equals false. And then what will happen is the next time we go through this, when it checks this fading, it will slip through to this second section where we'll actually be increasing the intensity until we are no longer less than 10 and we are in fact at 10. And then we need else, which will change is fading back to true. Check code. Okay, let's see if that works. Huh. Is it working? Oh, quite an important thing to do is trigger the block automatically. Otherwise it'll only run once. I think we could probably spam this, and yeah, every time we trigger it, and it faded, I don't know, it doesn't seem to be coming back. Alright, but yeah, we will automatically trigger the block in here, run time dot frequency, what is it, frequency something, update frequency. equals update frequency dot date. We're going to go the fastest one. This should be fine. It's not a very big script. It's not doing anything complicated. And reset. Resetting doesn't seem to actually be stopping. Okay, reset. Clicking reset. Resets. Oh. Setting fade needs to be false. Reset. Fade. Reset. Fade. Reset. Now, why is it not brightening back up? Okay. So this is working. Is fading. Nothing is reversing, is fading. So, oh, wait. Yeah, we are dimming. Dimming, 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 dimming. If the intensity is greater than 0.5, dims. Let's make this 10. And I want to see if it ever reaches this. So we should be able to reset and then set fading. And well, let's see where it's gone to. Intensity has reduced to 0.5. Let's reset. It reaches 0.5. Okay. Edit. If intensity is greater than 0.5, do this. I think we're stuck thinking that the intensity is still greater than 0.5. It tries to take 0.5 off, but it's stuck not being able to get it lower than 0.5. Let's play around with some values here. I think that's fine being F. Let's keep it consistent. And let's just change the picture code. Is that not? I'm doing it now. What did I do? Well, that could be the problem. What am I doing? You don't need the sign. We're taking away 1, 0.1, or adding 0.1. Right, there we go. Fade. It's doing it. Let's speed this up. There we go. Nice. Okay, that works so well. Let's add another one. What about flashing? That should be straightforward. All right. We'll want an argument. Flash. And a new setting, Boolean. Okay. ash equals true. There we go. Okay. So we can now add this one. Bridge lights run lash. Right. If setting lash yep. Now what we want to do is go through every light. Pretty simple. We just turn the blink interval on. Dot. One. And we have to set the length, otherwise it will be slightly off. And it'll be on less time than it's off, I think. 50% should work. Okay, let's see if it likes that. Let's just reset. Oh, and we are... Apparently we can combine them. What we need to do is every time there's a change, we have to reset. And then, boop, boop. Okay. What we also need to do is whenever we've set these to true, we need to set them to false when the other settings start up. So if we've gone to fade, we set fade to true, but we also have to set flash to false. And the other way around, if we set to flash, then we have to set fade to false. Okay, we're fading, and then we're flashing, and then we're fading. Cool. That seems to work. Question is, if we wait for the dim, yeah, I think resets the sets the intensity to 8. Cool. Right, now I think one last setting should do it, and that's where it's like flashing, but instead of all of them flashing on and off, half of them flash off and half of them stay on, and then they switch, and then they switch, and then they switch. So let's create the bool first, and we'll call this one swapping, or swap. We'll listen for the button. Oops. And of course we'll turn off the other two, and we will turn on the correct one. But while we're here, let's make sure that they're turned off there. And also reset needs these two, doesn't it? All three must be turned off. Yeah, it's okay. The order doesn't matter here because, yeah, nothing can intercept. Swap. So swapping is true, and now we have to put the second part of that in here. Setting swap. Then we run swap, and we'll create that here. Swap. And of course, we'll need the for each. Now, we're going to be using a different for loop here actually than the for each because we need, well, I'll show you what I mean. We need a for loop, a basic for loop. And what that looks like is it creates an index number, an integer, usually called I, but you can call it anything. Now, in this case, it will start at 0. It will then create a condition to which limits how many times the loop can go around. I has to be greater than some number. And if it becomes greater than that number, then the loop will stop at that point. So we're going to make it stop when it reaches the count of the lights list, because that's where we want it to stop. And then you have to set how the index number changes. And a short way of doing that is to say plus plus add, which means increment, which means just add 1 to this every time. So what will happen is this will start as 0, it will run the body of the loop, and then it will go back around again and it will check if it can still run the loop, and if it can, it will add 1, and then the loop will run through again, but this will be 1, and then this will be 2, and then this will be 3, and so on until we reach the limit. And that allows us to go through a list, one item after another, by sticking the I where the index number goes. And now we can, one by one, change properties. And we want blink interval. Oops. Blink interval. And probably, I think, 0.5 float was what we wanted to go for. And that should just work to make everything flash right now. If we just actually assign the button. Swap. Fade. Reset. I have broken it. False, false, false. I'm not sure why that's broken. Oh, I saw that. Assembly not found. Edit. Okay, what's going on? Well, first of all, indentation discipline. Let's just okay. What's it not finding then? Lights I. Could we just say naught? Does not contain a definition for blink interval seconds. Ah, yes, that's right. The items on the list are just block items. They're not lighting items. So we're going to have to do what we did up the top, which is, do we still have it or did I delete it? I think I deleted. Ah, there it is. There it is. What we do is for each time the loop goes around, we create a local variable at the point we are on the list, and we cut. That's a capital I, lowercase I. So this number goes in here. We cast to the right type, and now instead of this, we just refer to this local variable we created, which is of the right type. Now this will not ignore us anymore. Oh, that's the old flash. That's the fade. New flash. Nothing. Flash. Sets fade to false. Sets swap to false. Sets flash to no, we wanted swap. Okay, swap. Sets fade to false. Sets flash to false. Sets swap to true. Swap. Setting swap. Run swap. Can we just check this is even looping? Okay. Button panel, set of actions. Alright, I'll redo it. Lights, run, swap, confirm. Yeah, that's what it said last time. Edit, if, swap. I suppose the way to check is, okay, we've got blink left 50, we've got blink interval not correct. Okay, when I is classic mistake, I obviously has to be less than the count until it reaches the count and then it stops looping. There we go. Ah, look at it go. Notice how it's a faster blink because it's half a second. Right, that's just half of the problem. Oh, and yeah, that was saying loop. We can get rid of that now. Okay. Now the trick we're going to do here is we are going to set the odd numbers on the list to a certain blink offset, and we're going to set the other the even numbers to another blink offset. And the way you can do that is using a little mathematical trick called modulo. Now, if you divide, take the I index number, and you divide it by 2. Um, 0 will be 0 divided by 1 by 2 is 0.5, and 2 divided by 2 is 1 because there's 1, 2, and 2. And if you do it by 3, 3 divided by 2, there's 1, 2 in 3, but there's 1 remainder. Now what modulo does is it gives you the remainder. So if you get 3 divided by 2, the answer you'll get is 1. If you divide 4 by 2, you get 0 because there's no remainder. If you divide 6 by 2, you get 0, there's no remainder. Basically, every even number that you modulo by 2, you get 0 as a remainder. So if we check for modulo on index equals 2, the code body underneath, whoopsie, code body underneath, little screenshot there, will only run for even numbers. And then the else will run for odd numbers. This is the kind of little trick that comes up in coding interviews. So what we'll do for the even numbers is we will set light equals 50. So it'll be basically 180 degrees out of phase with the odd ones, which will just be set to that. And we'll leave the blink interval at 0, which is the default. And it works. Now, as you can see, the two next door to each other there are on the same phase. Because, as we found out earlier, this arrangement isn't in order. It's in the order that I place the buttons down. If we wanted this to all be strictly in some kind of order, maybe starting from the top left, going across to the right, we would probably either have to delete every light and then place them down again in that order, or we would have to go around naming them, which is ultimately what sets the order. The alphabetical order is what it goes by. Rename them like A, B, C, D, E, F, and so on. Or something like that. But this is good enough. Now the problem we'll have is when we try to go to a different setting. Maybe the flashing one. Yeah, and we find that they're still out of phase with each other. Because when we reset, we don't reset the phase. Well, we don't reset the offsets. Now where is reset? Here we go. Lights dot link offset equals 0, and that should do it. So we can go to the new blink setting, and then the old blink, and yeah, they're all in phase. And yep, that will probably do for today. Okay, as an exercise, what you can try and do is add a fourth setting where only one light comes on each time and the rest of them are off. So you get them running along, I don't know, they won't be in any kind of order that makes sense, but whatever order the list of lights is in, go from the start to the finish, only lighting one up each time. And next time we will go through how to do that. Have a happy Christmas. Bye.